In this example, we are going to be doing a limit. This time we're going to be plugging in as x goes to infinity. And so what I want to figure out is this a L'Hopital's rule kind of a situation? But before I do that, I would be, in general, you're going to be plugging in a limit, or you're going to be plugging in a value. So you have an infinity over an infinity, right? And so that is exactly the situation that warrants a L'Hopital's rule. We're looking for these kinds of scenarios, right? If you have a 0 over 0, a 1 over something, one of these. And so we're looking at this one. So I'm going to go ahead and start to do the derivative. But what I'm going to do is take a step back real quick and do kind of a pre-calc look at this. Anytime we're plugging in an infinity, we're looking for an end behavior. And an end behavior on this is we would have looked at, oh, the powers match. So we would have had a horizontal asymptote at y equals 4 over 2, which would become 2. So that is actually going to be the same thing eventually. So let's do the calc to justify it. And the calc in the past would have been, we would have divided every single piece by the highest power in the denominator. So we would have divided everything by an x to the third, simplified things out, and then plugged in our infinity, and it still would simplify to 2. But with L'Hopital's rule, we can maybe quicken that process here a little bit. So what that is us doing the derivative. And so if we do the derivative of this, we're going to get a 12x squared minus a 12x divided by 6x squared minus 10, right? But at this point, we still get an infinity over infinity if we were to plug it in. So we'll do it again. So x approaches infinity, and then we have a 24x minus 12 over 12x minus 10. We still plug in infinity and get an infinity over infinity. So we'll do it again. So we do this derivative, we're looking at a 24 over 12. We don't have an x anymore to be able to plug it in. So our limit is just 24 over 12, which simplifies to, not coincidentally, our horizontal asymptote of 2. But there's me, us justifying this value of 2 with calc. And that was using L'Hopital's rule to find a limit as x goes to infinity.